Hi everyone, Chinese Man here. Today we're going to talk about Python algorithm for merging two sorted lists. This is going to be an easy algorithm because, well, this is my first Python live tutorial on video, and yeah, I'm pretty rusty on algorithms for Python, so this will be something fun and something hopefully going well. But it also goes to show that once you master the algorithms and the ideas behind the algorithms and data structures, what language you use doesn't really matter that much, because although the syntax is going to be different, some of the available data structures might be a little bit different, the concepts, the algorithms, the strategies behind them remain the same. So when it comes to merging two sorted lists, this is in reference to linked lists. This makes it a little bit more complicated than merging two sorted arrays or merging two Python lists objects, for the simple reason that for those, you can iterate through them just using for I equals 0 to n, or JavaScript for each, or Python for x in array. But for a linked list, you have to keep track of which node you're at, and you have to, actually, yeah, that's the main thing is keeping track of which node you're at, making sure you don't try to access anything that is a null object and expecting a next node from that. So this makes it a little bit trickier, but the concept is still the same. When it comes to merging the lists, what you want to do is, for example, if you want to sort it in non-decreasing order, you have to make sure that you just add the smaller element of each list, array, or whatever other structure into a new list array. One thing to keep in mind is whether you're doing it in place or not, but here it doesn't really say that, so we're going to create a new list. Looking at the examples, for example, 1, 2, and 4 is one list, 1, 3, and 4 is one list, and that's our inputs. And we want a new list that's 1, 1, 2, 3, 4, 4. So notice that here in the constraints, we have that the lists are sorted in non-decreasing order. What that essentially tells you is that, well, first you have to ask yourself, why is it saying non-decreasing order? Why not just say increasing? Like, why be complicated? So part of that is to give you a bit of a intake into the edge scenarios. For example, what's the difference between non-decreasing and increasing? If it's in the same equality, for example. So that means is if you have a list that's say 2, 2, 4, that's a non-decreasing list, but it's not an increasing list because the first two nodes of 2 and 2 are still the same. So that means is there's going to be likely duplicate values within each list. And if there's duplicate values within each input list, then there's much more likely of a chance that there would be a duplicate value in your new list because, for example, here already, even though we don't have duplicate values in each list, we have duplicate values in the final list because both lists have 1 in it and both lists has 4 in it. So we're given here a definition of a single linked list, a class list node, which contains two variables. One is the value of that node, and one is a pointer to the next node. And that's just pointing to the next object of list node. So here the definition, we're given the merge to lists, we're given a list node of list 1, a list node of list 2, and one return list node. And our strategy is to loop through and combine the nodes based on which node is smaller until both lists are exhausted. What we do here is we initialize a variable of list node called head, and we're going to start at head. So I used result here because I typically, instead of trying to think about what variable do we use during a live code, I use result just because it's a little bit easier to, a little bit more constant. That's the thing that we're currently working on and we're keeping track of. But here actually, if we use the variable like current or cur, that would actually be a little bit more appropriate. But we're using result. Let's take a result. Result is actually going to be the variable that we're going to be going through as we make the new list. And we're keeping the head because as a separate variable, because notice that in this list, from the head you can always go to the tail, but you can't go from the tail back to the head. So you want to keep track of where your head is for a singly linked list. Even if it was a double linked list, you still probably want to keep track of it, because if they expect you to return the head, you don't want to, at the end, have to go back and iterate through your list, because that's extra operations, that's inefficient, and also it's extra code. So while either list is not empty, we want to run this loop. So why either list? The reason why you go for either list is, say for example, as an example, let's say we have list 1 is 1, 2, 3, and list 2 is 4, 5, and 6. Now what's going to happen is, when we're adding to the new list, then the result becomes 1, 2, 3, and then the first list is exhausted. We want to still keep on going because the second list is not exhausted. So we want to keep on going until both lists are exhausted. So that's the reasoning behind this, while L1 or L2 is non-null. And what we're going to do is we're going to move through both of these lists until we get to the end. Now, if they don't want you to modify L1 and L2, then you actually create a new variable. For example, L1 current equals L1, L2 current equals L2. Then from there, you can just modify that. So that way your original input variables aren't modified. But here for simplicity, we're just going to modify the original input variables. For good practice, you probably want to create the new variables, but for saving memory and for, I guess, because they didn't say, we're going to modify the existing variables. Now here we have a condition of if L1 is none, or if L2 is not none, and the L1 is greater than L2 in terms of value, we want to add from L2. So let's break this down into why we're adding from L2. So when we want to use a value from L2 to be the next node is if L1 is empty, well, there's no more L1, so you have to add from L2. Or if both are non-empty, check if L1 is greater than L2. So if both are non-empty, then we want to do a comparison. We don't have to worry about the case where L2 is empty for now, because that's taken care of in the else. But yeah, so these are the two conditions here of when we add from L2. And if we do want to add from L2, then what we want to do is for our current cursor of the new linked list, we want to set it to L2, and then we move L2 along. So for example, in this case, we look at these two, L1 value isn't greater than L2, so we'll take L2, actually, in this case, this isn't met because 1 and 1, it doesn't hit that condition. But in the second case, we have when the first list is greater than the second list. So say we're at 2, and we're comparing to the something smaller, or 4 comparing to 3, then that's going to get hit. And then it's going to take the second list, because it's smaller, current node, and then move that current node along. Now, that's for the conditions for adding from L2. The conditions for adding from L1 is essentially it's an else. So essentially, if these two conditions are not met, we want to add from L1. Now, when does that happen? Like, when would those conditions not be met? If L1 is not empty and L2 is empty, so therefore we don't really have any choice because L2 is empty. So we have to add from L1 because that's the only thing that's remaining. Now, how do we know that L1 is also not empty? Well, this loop is only in place if at least one of L1 or L2 is not empty. If both were empty, this loop would have stopped. So we know that at least one of L1 or L2 is non-empty. And based on this first if the list L1 is none. So because this didn't get hit and this got hit, then by default, it means that L1 is not none. So therefore, we have this from this part, and then we have this from that. So if the first list is not empty, if the second list is empty, we can only take from L1. The second condition is if L2 is greater than or equal to L1. So where does this condition come from? It comes from here, where this looks at it if L1, and both L1 and L2 exist. So this did not get triggered, and because we're in the else, we know that L1 is not empty, and L2 is not. So here, in this case, if L2 is greater than L1, that means that the L1's current value is smaller, and we want to take that. And we just do a similar thing here that we did before, where we just take the results.next equals to the first list, which adds it on, and then we move L1 forward. So this is exactly the same as what we did earlier, except that now we're taking from L1 instead of L2. And then this line here essentially just moves the result along. So say we're at 2 here, and we added the 3 by result.next equals the 3. If we stay here for the cursor, the next time we try to add to the next, it just replaces it, and doesn't really. That's not what we want, because we still want to keep that 3. We just want to add to the next one after that at the end of the tail. So this just moves result along so that the result cursor points to the end of the tail. And this keeps on going until both lists are empty. Once both lists are empty, that means we've added everything from list 1 and list 2 into the new list based on the order as we desired. And then from here, we just return head.next. So the reason why we're returning head.next instead of head is, notice that here head is a list node, but we never assign head directly any value. When we do result.next, at the beginning, result equals to head, and head.next is equal to L1 or L2. So therefore, result.val is always none. So in that case, result.value is not necessarily none, because here we have a default parameter of value equals 0. So value equals 0, but that's not part of our result set, so we don't want to keep that. That's why we want to return head.next, which is the first real sorted node that we took from L1 or L2. And that's it. So the thing about linked lists is it's very easy to get mixed up in terms of keeping track of where you're at in each of the respective lists. It's very easy to get mixed up on conditions. So I got mixed up a few times even though I wrote the code already. So the key thing to do when dealing with linked lists is breathe, take your time, and if you make mistakes, which you might, when you click on run or submit, when you're doing an interview, you'll be running, some interviews will have the ability to actually run the code, and some interviews won't have the ability to run the code, but if it does, you can test to see if it actually had the right results. So for example, you can create L1 equals 124, L2 equals 134, and then see if the final result matches by iterating through and printing that. Some of a problem of creating those test cases is for linked lists, it takes a lot of effort to mock that up. So what happens is, if we wanted to create this very simple example of 124 and 134, if these are two sorted arrays, it's pretty easy. L1 equals parenthesis 124, L2 equals parenthesis 134, and then you have your results, you can just print that and you have this. Now with linked lists, it makes it a little bit harder because you have to make a L1 node of 1, then pointing to another, the next is another node of 2, which points to 4, which is also another list node. So you have three list nodes in one, which you can create by, for example, L1 equals to list node of 1 and next, which gets a little bit messy because what is next? Next is another list node of 2 and next is another list node of 4, and there's no next. So notice that this gets a little bit complicated once you start getting more in depth. And then finally, when you want to print the last, resulting list, you have to iterate through that and print at each value. Because if you just print the head of this node, you're just going to get an object of list node. If you convert a dictionary, you have an object. You have a dictionary of 1, comma, no list node, which doesn't really do a lot of good for in terms of showing what's the entire linked list. So that makes testing a little bit harder, but it's okay. Keep at it. Just to make sure you take your time. And if you do make any mistakes, don't freak out. Just go back and correct it. And that's it for this video. We might do some more Python videos in the future. We'll definitely do more JavaScript videos in the future. So make sure you hit that subscribe button.